Welcome to the project demonstration of solar powered grid status monitoring and alerting with Android smartphone technology. So in this project we are mainly making use of PIC microcontroller to continuously measure the solar and battery voltages continuously and monitoring the same status along with the temperature on the LCD screen, as well as uploading the same data to the mobile phone application through the Bluetooth technology. So for that purpose we are making use of this HVS-4845 Bluetooth module to continuously data monitoring on the mobile phone. And here major components are like solar panel and battery. This can be recharged through the solar panel or grid. So mainly the project is demonstrating based on the solar panel only. So while demonstrating the project, connect this S solar panel pin at this slot T by S. T for transformer. Whenever the sunlight is not available, then we can recharge this battery with help of this transformer. So this is the transformer section, which is take the 230 volts AC input and provide as the 12 volts of AC outputs. So now we can see the low light intensity from this charging circuit, which will show the status of light availability on this solar panel. So when the more sunlight is available, then we can get the more light intensity from this one. And now, so while we're demonstrating, we need to connect the solar panel over here. As this charging circuit consists of 4 diodes, which will acting as a bridge rectifier. The main bridge rectifier purpose is to convert the AC to pulsating DC. But in our project, when we are providing the solar panel inputs, it is a DC, but then these 4 diodes will act as a polarity corrector. Means if we connect the solar panel in reverse polarity, means reverse direction, then also it will get plus to plus, minus to minus. As we are using these 4 diodes, then we will acting as a polarity correctors. Means input any polarity, output plus to plus, minus to minus, and then the stage is capacitor, just in order to remove any ripples occurred while doing this rectification or polarity correction. And then after the output is fed to the LED, and again to the through these 2 diodes we are providing that to the 12 volt 1 amp battery pack directly. So then these 2 diodes will block the current flow from the battery to the solar panel whenever it is fully charged. So these 2 diodes will acting as a unidirectional current flow purpose. So the output from the charge circuit is input to the battery pack, and parallelly we are measuring the battery pack voltage with help of this voltage sensor, solar panel voltage with help of this voltage sensor. So these 2 sensors look like same, and they have the 10:1 potential divider ratio, that is with help of resistors. So we are using 10 kilo ohm and 1 kilo ohm resistors. 2 resistors we are using for input purpose, and output we are measuring voltage across the 1 kilo ohm, so that we are getting the 10:1 voltage ratio. When we are providing the 12 volts input to this voltage sensor, then the output from this voltage sensor is 1.2 volts. In the microcontroller we programmed it to multiply that with 10. Here we have interfaced the 2 voltage sensors at A0, A1, and the status continuously monitoring on the LCD B2 to B7 connected, and temperature sensor of this surrounding system will be monitored by this temperature sensor connected at pin number A2, and the Bluetooth module for sending data continuously to the mobile phone to the Bluetooth, that is interfaced at the B0, B1, and whenever the high temperature occurred, then we will get the audible alert through this buzzer. So this is all about the components. And whenever you want to charge a battery when the sunlight is not available, connect the transformer, and on the power supply to this cable, there we get light indication, and it will get fully charged in a duration of 4 hours maximum. Till the duration we should keep the battery under charging, either from the solar panel or from the transformer. It will take the same time. So after the time, automatically the charging circuit will block the current flow for the protection of battery from overcharging. Now before demonstration, on the Bluetooth in your mobile phone, and install this application. So this application we need to install from the Play Store. Any application, if it is not available in the Play Store for your respected Android version, then install any serial monitor application, and after that we can on the power supply to this kit by just switch on this. So welcome message displayed on the LCD screen, and then solar panel voltage and temperature in degree centigrade, and battery voltage monitored on the LCD. Battery voltage is 12.2 volts, as well as solar panel voltage is 2.8 volts, as the low sunlight intensity available on the solar panel. Now just go to Bluetooth settings. When you are demonstrating the project very first time, we need to pair through the settings. so that it will be there in our paired devices. So next time onwards directly we can go to the application part. Now search for a device HC05. So when we can see the HC05, we need to pay to that by entering the password. So the password is 1234, right? We got it. So password is 1234. So after pairing successfully from this, now go to the application. It will be there in our paired devices. Means that you can see from here. Now select HC05. So the device is connected, right? Okay. Once it's connected, we can get the data streaming continuously. Whatever the data is appearing on the LCD, same data we can see on this mobile phone also. Right, and now just we can increase the temperature. We can see the temperature increases whenever it crosses the 40 degrees centigrade. Then we can get audible alert through this buzzer, and the same alert message can be seen on the mobile phone also. And again it is normal below 40 degrees centigrade, then it is normal. And it's a continuous process of the solar grid status monitoring along with the solar panel voltage and battery voltage along with temperature, with protection of over temperature near this system. Right. Thank you.